Hello everyone. In today's session, we are going to see the passive elements of electrical circuit. In almost all electrical application, one has to go through three passive elements: resistance, inductor, capacitor. In every application, you will be finding these three elements. So, having knowledge of these three elements is utmost important. Let's only focus on resistance for now. The proper definition of resistance is it is the opposition to the flow of current. Before going to the concept of resistance, I would like to give an example, real life example, which you can correlate with the resistance. Let's take the example of Savitribai Phule, who started school for girls. But the people in the locality opposed her decision. They tried to put many obstacles in her way. So, from here we can say that Savitribai Phule was leading her life with the firm decision to start the school for girls. But the people in the locality opposed her. So, the people was nothing but the opposition to the decision taken by the Savitribai Phule. So, those are that opposition provided by the people, we can say it as a resistance, and the decision taken by Savitribai Phule, she was leading in that decision, we can say that it is the flow of current. So we can correlate the things like obstacles are nothing but resistance. Also, we can say that life is never easier. In life we have to face many hurdles, and that hurdles are nothing but resistance in electrical circuit. Same way, in electrical circuit, when we apply a voltage, current starts flowing, and that current is opposed by resistance. And resistance is present in every conductor. But if we want to limit certain amount of current, then we have to provide an external element called resistor, and resistance is its property. Don't get confused. Resistance is the property of the resistor. Now let's see how the conductor itself opposes the flow of current. Conductor. Copper conductor. Copper is a solid conductor, right? In solid conductor, whatever may be the conductor is made up of atoms, and those atoms are strongly bonded to each other in solid conductor. So all the atoms will be sticking to each other, and they will be vibrating about their mean position. Suppose this is an electron. If an electron wants to move from this place to this, he has to face this vibration of these atoms. So the opposition provided by these atoms to the flow of electron is nothing but the resistance. Because of this opposition, the speed of electrons will reduce, and therefore the current, since the current is caused due to the flow of electrons. Also, we can give another example for voltage, current and resistance in electrical circuit. We can correlate these things with the water pipe in our homes. Say this is a tank. Another tank. This is the ground. Now, we can say that this water is having some potential energy, right? Even we ourselves also have some potential energy. Now, how much potential energy it may be having? Weight mg and the height mgh, and this also mg and certain height h. Because of this height, there can be a flow of water from this to this through a pipe, right? This potential difference is nothing but voltage in electrical circuit. Now, water will start flowing from here to here. That flow of water is nothing but current. But now this is voltage, this is current. Now what exactly is resistance and where resistance is playing the role? Let's take the example of water tap in our house. When we open the tap completely, a wider stream of water comes. That is no resistance offered. But if we open the tap little only, we'll get a narrow stream of water. That is, we have opened only a small hole, means the resistance offered is more. So the stream of water is narrower, right? इसलिए तो पतला पानी आ रहा है ना, क्योंकि तुमने नल ही पूरा नहीं खोला है. नल पूरा खोलोगे तो होल बड़ा हो जाएगा, इसलिए पानी आसानी से आ सकता है और इसलिए मोटा पानी आएगा, राइट? दैट इज़ द रेजिस्टेंस. So even so from here we can derive the formula for resistance. Actually, resistance is given by rho r is equals to rho L upon A, where L is length of conductor, A is area of cross section, and rho is resistivity. It is the property of material. Now, अभी if this much is whole, obviously water will be less. इतना बड़ा अगर होल रहेगा तो पानी ज़्यादा ही आएगा. So resistance कम, sorry, if area is less, this is area ना, area कम है, water will also be less, so current will also be less. What is analogous to water in the electrical circuit? Current. So if area is less, obviously water will be less, therefore current is less. Your area is more, water will be more, so current will be more. So we can say that water more है मतलब resistance कम है, and your area is less, current is also less, मतलब क्या है, resistance ज़्यादा है. So we can say that resistance is inversely proportional to area of cross section. अभी now again we'll take one more example. अगर रास्ता छोटा होगा तो हम आसानी से चले जाएंगे, लेकिन रास्ता बड़ा होगा तो और भी मुश्किलें आएंगे. वैसे ही लेंथ, इफ़ लेंथ इज स्मॉल, resistance will also be less. If length is big, resistance will also be more. So resistance is directly proportional to the length, and rho is resistivity. It is the proportionality constant. R is equals to rho L upon A. Equals to, if rho is equals to 0, मतलब resistivity ही 0 है, then it is called as superconductor. means pure conductor, no opposition. Even a small bit of resistance is also not present over there, purely conductivity. Then it is called a superconductor. An example is mercury at 4.17 Kelvin. This is the temperature. At this temperature, its resistivity is 0 and it acts as a superconductor, and it is called as, and an example is mercury. So this is what exactly is resistance. Now, there are two connections for resistance: series connection and parallel connection. Let's see series connection. R1, R2, V. Let this be current. Now, here two resistors are there, R1, R2, and we have provided a supply voltage V, and when we apply the voltage, current starts flowing through it. Now you can see the direction movement of the current will move like this through R1 and then through R2 and back to the battery. So now, since the current is same in both the resistors, in series connection current will always be same in each and every element. So this is the series connection. In this case, we can give an equivalent resistance as R equivalent is equals to R1 plus R2. In this case, the voltage will be divided across R1 and R2. Here, let the voltage across R1 be V1 and the voltage across R2 be V2. How we can find out V1 is V1 this I into R1. V2 is equals to I into R2. So this is the basic thing for series connection. In series, current remains same, whereas voltage get divided across each element, and that voltage is proportional to the current. V1 is equals to I into R1, V2 is equals to I into R2 according to the Ohm's law. Now, another type of connection is parallel connection. This is voltage R1, R2. Current. If we see voltage is applied to the resistor element in parallel. Now current starts flowing from here. Here current gets two ways. You can say like if a person is moving from here, he finds two ways, two roads. So so these are two ways. So current will split itself in two ways. Here it will go I1 and I2. This I will be equal to the sum of these two current, I1 plus I2. Here V will be equal to V1 plus V2. So this current is getting splitted in two parts, I1, I2. In parallel, the voltage remains same, and voltage across R1 will be V1. Voltage across R2 will be V2. In parallel, voltage remains same, whereas current gets split. Now, how we can find the current? I1 is equals to V1 upon voltage across R1 is equals to V1, voltage across R2 is equals to V2, but V1 is equals to V2. Don't confuse by V1 and V2. They are nothing but same only. This voltage across this resistance and voltage across this resistance is same, that is equal to V. That is supply voltage. So what will be I? I1 is equals to V1 upon R1. V1 is nothing but V upon R1. I2 is equals to V2 upon R2, but V2 is nothing but V upon R2. In parallel connection, voltage always remains same whereas current gets divided. In this case, 1 upon equivalent, to find the equivalent resistance, there is formula 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2. Always remember, in parallel connection, voltage remains same whereas current gets divided. In series connection, current remains same whereas voltage gets divided. So this is the brief idea of resistance.